good afternoon, students. So, myself, Dr. P. Chandana, working as an associate professor in the Department of CSC, IARE, Hyderabad. So, today I'm going to deal with the subject of computer organization and architecture, where in this particular subject, we are focusing keenly on the things like how exactly computer is represented, what are the internal components of a computer, and how each and every component is working, how they are interconnected with each other. We are trying to see the interfaces between them, and we are going to see how the interaction among all these components can serve better for understanding or presenting the results to the end users. So here the end user is nothing but a person who is communicating with the system. For example, I am the person end user who is communicating with my laptop, or you are the end user who is communicating with your laptop or desktop or PC. So we are just giving the queries, but how internally it is being organized, how it is internally performing its operation, so that your understanding of the things have been going well, and the queries which you are giving is being correctly presented, and it is been giving you the results in a proper manner. So in between there are so many things that will happen. So we'll discuss these things in the subject called computer organization and architecture. Now we are starting with a basic topic like computer organization introduction. So what are you learning this? What do you learn in this particular topic? So in this particular unit, you are going to learn about the basic things of a computer. So what do you mean by a computer? How exactly the functional units are there? What are the basic units we are having? What are the key components we are having, so that we are having a better understanding of a computer? So let's start with the basic things. And just in this particular unit, we are going to discuss about the things like basics of the computer units with respect to functional units, with respect to operational concepts, with respect to system organization, CPU organization, how the memory and IO organizations have been generated. So we see all these things in the internal with the keen components and keen understanding in each and every turn. But let us start with the basic things of what exactly the computer is. So we start with introduction, basics of a computer or a computer. So in general, what do you mean by a computer? Computer, as a simple definition which you used to learn from the basic things, computer is nothing but it is simply a peripheral device which accepts input and process the information and presents the output. So let's start with the basic things. Now, so as a definition we suggested, computer represents that we are saying that it is a peripheral device. That means it is some device. Now it accepts input. So we are saying that input is accepted. Now what it is good doing? And it is presenting you the output. So this is a output. Now, what did I say? It is a peripheral device which accepts the input, process the information and presents you the output. Now, what do you mean by process here? So here, process is the major task which a system has to done or which a system has to do. So here I am saying that input is given and I am presenting the output. Now, what is the input? So let us start with the example. C is equals to A plus B. Now, here C is equals to A plus B. This is some basic definition. Now, C is equals to A plus B. Let us consider, I am considering A is equals to 10, B is equal to 20. Now, I will give the result as C equals to 30. Now, what is happening here? I am taking two inputs. A and B, which is considered as 10 and 20. Now, it is being processed with a simple operation called plus, and it is feeding the result into C, which is equals to 30. So this is a basic idea of a processing. Processing is nothing but what exactly the task I need to perform, what task I have to perform. We can also say that the basic operation which has to perform is also called as processing. So this is composed with the context of input is considered to the device, peripheral device, and it is being performing the process. It is being performing the processing and then it is presenting you the results. So this is the way you are going to see with the operations of a computer. So the general basic definition we will be revising once again. It is a peripheral device which accepts the input and presents you the result by processing the information. So what is the information here? The data which you have given. So what is the data you have given? A equals to 10, B equals to 20. Now what is the operation you have given? It is plus. So what is the result we got? 30. So it is being fed to the output device. Now, what do you mean by input device and what do you mean by output? We are simply saying input is given, output is displayed. Now, by using which portion we are giving the input, by using which device we are getting the output. So, for giving the input operations, we need to present with the input devices. We have a special concentrations where you have to consider it as an input device. For example, I am writing something on the board. So this board is nothing but an input device. So that means this is a pen which is acting as a stimulus to write the content on the slides. Now the output device, it is a monitor where your data is going to be displayed. So we need to have a special device called as output device. So it accepts data from the input devices, process the information and presents you the result to the output devices. This is a basic idea, basic definition of a computer. So this is about the case. So let us come back to the same computer definition once again. Now we stated that computer is a peripheral device which accepts input. So we can say the combination of computer as a simple block diagram like this. So it is taking the data from the input devices. It is giving the processing information and it is presenting you the output. It is presenting you the output. Now, when it is presenting you the information, it has to perform some operation. For example, just now we said that C is equals to A plus B. Now, plus is a task which I have to perform. Now, in order to perform this, it is a plus. For example, in some cases, I may write C is equals to A plus B. In some cases, I may write C is equals to A or B. In some cases, I may write C is equals to A into B. These are the different tasks of operations. Or else in some cases, I may write load C with 10. So these are the different operations I am performing. So how these operations have been generally involved or generally understood by the machine is been basic concept. In order to consider this, we have to consider the processing information by means of a special units inside the processing device. So we are saying that it is taking data from the input and presenting you the results from the output device. Fine. But in between, it has to process the information. I don't mind what kind of process I want to give. I'm simply giving the data to the system. Now, this is called as processor or simply in the words of CPU. Now, this will have internally three basic components to perform. What is the task given? What is the task given? What was the input given? How it has to process and how it has to present. So these are the things which has been involved in the processor. In order to get this, we need to go for a simple case of three basic things, basic units in this. One is memory unit. Second one is control unit. And third one is arithmetic logic unit. These are the three basic units involved in the processor, which considers the data from the input source, processes the information by understanding that source, and presents you the results. So each of these devices are bidirectional. It is connected with each other because it has to collaborate with each other. It is connected with each other. So in this way, the data has been collaborated in the computer. The different functional units have been connected with each and every component inside the processor. So this is the basic idea of computer. Now let's start with the basic things, basic functional units. Just now we have discussed input-output unit, and arithmetic logic unit, control unit, and memory unit. So what is this actual? Just now we said that it is the input device or it is the data is collected from the input sources, processed and presenting you the results. Now, in order to collaborate, in order to understand these things, we just define the basic components of this and we'll see how the different components are considered. Fine. So what are the basic components we have seen in the computer? The first thing is input-output unit or input-output devices. So we can say this as a functional units. So the basic functional units in the computer, we start with input and output. Next one is internal operations. So we started with the memory unit. Then we are going with the next case, arithmetic logic unit. And next thing, we are going for control unit. So these are the major components or major units inside the computer. Now, We are going to discuss about how these units are exactly performing its operation, what exactly the objective of these units inside the computer. Now let's start with the first one, iBio devices. So iBio devices, as a name it is suggested, we are concentrating on considering the acceptance of data from the external source and presenting data to the external source. That means accepting data as an input and presenting data as an output. So we have a special devices. Its main objective is to just accept the data and present the data. So we can simply say that accept plus present the data. Next, memory unit. So as a name it is suggested, we have been considering this memory unit basically for the major objective of storage or access. Storage or access. So major intention here is to understand how the data is stored or where the data is stored and how it can be accessed from the source. The next one is the basic idea here is the next unit is arithmetic logic unit, where it is being considered with the operations of both arithmetic and logic micro operations or arithmetic and logic operations. For example, I have written C implies 10. I have written C is equals to A into B. I have written C tends to A plus B. So these are the arithmetic operations and this is a transfer operation. So all these kind of operations are performed in arithmetic logic unit. And the last one is control unit. Now, the basic idea here is to understand what exactly the objective of control unit. The basic idea with the name of control is nothing but it simply controls and coordinates all the units. We said that iBio collects the data from external sources. Memory is used to store the data. Arithmetic is used to perform the operations. Now, who will collaborate this? Who will initiate the tasks for this? For this, we need to go for a control unit. In order to initiate the control operations, that you have to collect data from memory, you need to collect data from iBio, you have to present data to output. All these things are being considered and collaborated by means of a control unit. So the basic idea of control unit is to simply control all the units inside the computer. So control all the units or else simply collaborate with all the units inside the computer. Collaborate with all the units inside the computer. So this is the basic idea of handling the different units in the computer. So we just see the overview of these things with the basic components. So what you have done? You have been given with iBio sources like input-output devices. Next, what is the operations you have performed? Memory, arithmetic logic unit and control unit. And it has been connected with all the links, that is by means of a interconnection network. These are the basic functional units of a computer. Now let's start with the basic operational concepts. So in order to explain this, we'll start with an example and we'll see how the operations of a how the operations of a CPU or a computer is being operated. So this is just an overview. Maybe you don't understand these things clearly. Let's start with the example. Now, let us consider the example. We are writing some instructions. For example, many of you have written with the C programs and all. So, might have written with the C programs like include. You might have written with the statements like include, main, printf, followed by, if at all you have performed any operations, you will be performing those operations. And finally, again, printf C. Printf of C. This is a basic example which you are familiar with. Now, how these instructions, these are generally high-level language instructions. Now, how these instructions are generally operated, how these instructions are generally executed inside the computer. So, in order to understand this, we just consider one more example which you can clearly understand with the simple statements. First one is load R1, LOC. Next is add R2, R3. Sorry. R1, R2 with R3. Next, store R4, LOC, R3. So these are the three basic examples. What does the statement represent? The first one is a simple C program which you are already familiar. internally, what are the high level language constructions you're doing, what are the high level language programs you're writing, those are generally converted into simple notation called as, or mission notation called as, assembly language notations. The second one is the example of the assembly language instructions. So assembly language instructions. So instruction means each and every line. So whatever the lines you're reading, what are the lines you're calling, all these things have been considered as a instruction lines or instructions. So it is simply nothing but a guidelines to the execution. So include means it should include the header files. Main means it should call the control. Printf means it will print the data. C equals to A plus means it is performing addition of two numbers. Printf means it is performing a printing of C value. So these are the examples which has a specific importance. Similarly, when it is converted into mission notations, it should convert into intermediate language. That language is called as assembly language. The first example is not meant for the second one. Just an example, we are considering two different formats. One is simply a case where you are writing C equals to A plus B. And second one is the assembly language instruction where you are writing three instructions. One is you're loading some value, you're adding the values and you're storing back the values. For example, I am considering one location LOC, and in that LOC, I am maintaining some value 10, for example. So in this value, what I am doing, so I am just considering this value and I have to perform some next operations on this. What I am doing now, LOC is being loaded with R1. Load R1 comma LOC means LOC value is now loaded into R1. Now, what happens here, the 10 which you have been holding in LOC, it is just making a copy of 10 to R1. That means ROC and R1, LOC and R1 both will have the same value of 10. Something like example of call by value, which will maintain a duplicate values in both LOC as well as R1. Now, the second statement is add R1 comma R2 to R3. So here R1 plus R2 implies R3. R1 plus R2 implies R3, which means that R1 is having already a value 10 and R2, I don't know, it is having some other value, for example 20. Now these two values are appended or added and this been stored in R3. So now the new value is R3 implies 30. R3 implies 30. Now what is the third instruction? The third instruction we have is store of LOC comma R3. So store of LOC comma R3, what happens? Already we have a LOC with a value of 10. Now we need to store this R3 into LOC. Now what is the value of R3 now? Now it is being considered with the R3 to LOC, which means that R3 is holding the value of 30, LOC is holding the value of 10. Now this is overwritten with a new value. Now LOC will become the new value of 30. LOC will become the new value of 30. New value of 30. So this is the way how we are organizing the operations of the instructions inside the concept. Now this is just an example how the program is getting executed. Now what is the key impact over here? Why do you want to understand this particular language, this particular instructions? The concept here is basic operational concepts. Now we have in the previous slides we have been discussed about what do you mean by a computer, what are the functional units, what are the importance of the functional units. Now in this case we are seeing that three statements are there. One is the load, second one is add, third one is store. Now how these three things are exactly written? You are writing a program and you are simply saving with the .c extension or .python extension. Now how these are executed in general? So for this you have to understand from where these programs are fetched, where this is getting executed, how this is getting executed. In order to explain that, we have just taken one example with the three basic instructions. What is the impact or what is the problem or what is the meaning of this instruction is given over here. Now we start with the operation. What are the units we have said in computer? We will be having memory unit, arithmetic logic unit and control unit. And other things which are connected is input output unit. These are the basic functional units. Now what did I say? We are storing the data in LOC and it is been loaded into R1. So that means R1 is loaded with LOC. This is the data. Now what is the LOC value we have? 10. And what is R1? We don't know. Now where the data is stored here, where the 10 value is stored, where the LOC value is stored, all these things are the major concerns. Because of this reason, memory unit is a place where the data is stored. So for understanding these things in clear, we are going for this kind of example. So the basic operations of these three instructions have been explained now. Now we are saying that first statement which you are executing, or the statements or a program which you are executing, first it is loaded in memory. So let's start with the basic operations. So what is the first thing you're doing? You're saving your program. You're saving the program. Now, when you save this program, it is stored in memory unit. It is stored in memory unit. Now, once the data has been stored in memory unit, you have to execute. Execute in the sense it should compile, it should run for the errors, and it has to execute the output. So these are the three things you have to consider. Now, what was the previous instructions we said? We have been given with the three instructions: load R1, LOC, add of operations, and store operations. These are the three basic operations we already have. Now, first we have been loaded the data into memory unit. Now, it has to execute. What is the first thing we have done? Load operation, which is already in memory. Now, what is the next instruction? Add. Add is the data where you are considering two values and you are appending the things. Now, what are you adding? R1, R2, and R3. Now, R1 is already loaded in memory unit. Now, what about R2? That is also loaded in memory unit. Now, R3 is a next source where you have to get the data that is added. Now, R3 is also one of the unit where you have to hold the data. And now, in this particular case, we are just adding, or we are just making the external source as a basic things, or making some external source to hold for some temporary time. So these are called as general purpose registers. These are called as general purpose registers. General purpose registers are the registers which keeps hold of a data for some time, not for a long time. For example, if our data operations is frequently changing, it has to hold the data for some time of execution. For that purposes, we'll be making use of this particular operation. So these are the general purpose registers where you are making data to be loaded in R1, data fetched from R1 and R2 is added to R3, and it is been stored again to LOC. So these are the three basic things you are performing. Again, the next instruction which you are following is store. So store is following the data into R3, LOC. That means R3 data is stored in LOC. Now R3 data is stored in LOC. Now again, LOC is also available in memory unit. R3 is having a data, it is fetched onto it is loaded onto the LOC. So that means data in LOC is now overwritten with a new value. So these three instructions are generally operated by means of a memory unit. Now this add instruction which you have been calling up, this is being called up by means of a arithmetic logic unit. So that means what are you doing? First you are saving your memory and you are trying to execute. So for understanding this, we will go for two special registers called as instruction register which holds of the each and every instruction. That means what is the line I am calling, which line is getting executed, which line has to execute, or which line is the next instruction to execute. All these things are also one of the consideration. Till now what we said, we have written the program, saved in memory, fetched that, executed that. But internally, each and every memory is being called up and it is being executed. When each and every line in the program is called up, it is executed and it is been giving you the results. For understanding this, we are going for a combination of the program which is already given with the example. Now, we said that it has been saved in memory unit. Now, it has been given with the instructions. Now, what is the first instruction? Load. So, load is being loaded into instruction register. Now, what is the next instruction? It is add. So, we need to keep track of the next line also because it is loaded in memory. It is been in an indefinite location. So, we have to get the next location also. For this, we'll go for a program counter. Program counter which keeps track of how many lines are there in the instruction, how many lines are there in a program, what is the next instruction that is being fetched. So program counter keeps track of next coming operation. Program counter keeps track of next line to be executed, and instruction register keeps hold of operation which is currently executing. The current execution of instructions are loaded in instruction register. The next instruction that has to execute is loaded in program counter. The temporary operations which have been performed by means of temporary locations, those have been maintained in general purpose registers. and the data which is fetched from memory that has been loaded into main memory and process memory interface. And next one is control unit, which keeps track of all the operations to navigate properly or to work properly or to connect properly or to execute properly. The control unit is taking care. These are the things which have been considered. The other combinations which you can also see is, the processor memory interfaces which you're talking about. It's generally a name, but internally it has to call the data from the memory and to present the data into memory. For example, data has been fetched to LOC to R1. That means data is coming from the memory. Next one is the data is added to R2 and R3 and R1 and R2, and then the next is data is again reloaded into LOC. That means data is fetched from memory, data is loaded onto memory. For understanding this, the processor memory interfaces which you're talking about will possess two basic registers. One is memory address register. The second one is memory data register. Memory address register and memory data register. So these are the two basic registers which takes care of getting and fetching a data from the memory and loading data onto the memory. So the memory address register gives you the location where the data has to be fetched, and memory data register holds the data from that particular location. So these are the two basic registers which are acting as a interface to connect main memory and the processor. And this is a complete processor interface. So in this way, the basic operational concepts are being generated. So what are the things we have been discussed till now? It can be segregated. It can be simply concised into basic components. We are considering this as a basic computer organization. So the data over here is a basic computer organization. We'll have the same functional units and same operations. So initially, I've just given with a simple idea that iBio is connected to processor. But internally, the organization of this can be fabricated in so many other ways. CPU is connected with memory and iBio. Okay, the thing which you are connecting over here is being explained over here with a simplification of a design. Now, this is the way how the data or how the components are connected internally. Now, we said that in the initial case of example, I think in the definition of a computer, we have said that each and every unit inside the processor is being connected among bidirectional operation. So memory unit, control unit, and arithmetic logic unit. We said that it has been connected in a bidirectional operations. These connections which you are making over here is also one of the consideration which you have to concentrate. So because of that reason, the basic computer organization which you are seeing is having the same components once again, same things once again. So we are saying that memory is connected, iBio device is connected, and CPU is connected. Now how these things are connected? It is a bidirectional operation. So here data is connected from CPU to memory, CPU to iBio also, even from memory to iBio, memory to CPU, that is bidirectional. Now in order to connect this, we need to have a special interface called as bus. Special interface called as bus. So in this special interface, we are concentrating on to whom I have to connect, what is the data I have to process. So two things you have to concentrate. And what is the initiation made? Should I accept or should I load? So these are the two things. So because of this reason, the bus is connected with the three combinations. So the bus is nothing but it is a special interface with a group of lines which has a combination of data transfers from each and every unit. So it is I just repeat the definition once again. It is a interface or a communication interface which has a group of lines as a communication lines to interact with each and every unit. So generally bus is composed of three basic components or three types of buses. One is to locate, that is address bus, and to possess, that is data bus. What kind of operation? That is control bus. It is a group of lines which communicates with each and every component internally in the computer, which possess three basic things, three things of operations: address bus, data bus, and control bus. So first thing is address bus. As a name it is suggested, we are trying to locate, and it is unidirectional because a address of any component will be unique, or address of any location in memory will be unique. Address of any device will be unique. So because of that reason, address bus will be only in a unidirectional operation, only in one directional operation. Second one is data bus. As the data has to process from to and fro operations, it is bidirectional. It is bidirectional. And operations on the components are also bidirectional because we don't know either to data retrieve or to present. So because of this reason, control unit also, control bus is also processing with the bidirectional operations. Now, here we are talking this with the context of memory unit and a IBIO. Now, why you are calling this as memory subsystem and IBIO subsystem? So here we are saying that memory is a component where the storage is maintained. Now we don't know how much of storage is there, how many types of storages are there. Now because of this reason, memory is connected with so many combinations of memories like primary memory, secondary memory. There are so many combinations like secondary storage devices, primary storage devices, RAM, ROM, so many other components are there. Because of this reason, we will be concentrating this as a combination of memories, that is memory subsystem. And now, once you connect with IBIO devices also so many things. The general example we have is keyboard and mouse. These are the two input devices. Pen, it is also one of the input devices. So here, the combinations which you are taking as a devices like IBIO, like for example, I am presenting on TV, I am presenting on PPT, or I am presenting on OHP. All these things are the output devices. So because it is a combination of both IO devices and so many other so many units, we'll be considering this as a IBIO subsystem. Yes, for a general example, we are considering input devices are 2 and output devices as a monitor. So 2 input devices are there, 1 output device is there. So we'll consider this as IBIO device 1, IBIO device 2 and IBIO device 3. So on how many devices you are connecting. Because it is a group of IBIO combinations, IBIO devices, we are calling this as a IBIO subsystem. Now, IBIO device 1, IBIO device 2, so on up to n. We can connect n number of devices that are already available. Or if you want to connect, you can also connect external components also. Now, here also IBIO device is having a unique address. Because of this reason, the address bus is unique. Similarly, data bus is bidirectional. So, data is combination. The bidirectional operations. And next one is third case is control bus. So control bus is also possessing different control signals. So in this way, the IBIO devices are connected with each other. Now, this is a line which represents that combination of lines. We said that bus is a combination of lines which helps us to communicate with the data transfers or address transfers or control transfers. Now, as it is a combination of lines or a group of lines calibrated to connect the communications or to present the communications, it is represented as a group. The group is represented with a simple slash. So, in general, it will be having some large cable, but internally it is represented as a single line with multiple slashes. So, in this way, it is connected with the basic computer organizations. Now, so these are the basic system components which you have already discussed. So these are the 3 components which you have already discussed. Next one is a combination of buses which you have already discussed with the system bus, address bus and control bus. The basic idea of address bus is to data presentation or data location representation. Where exactly data is coming from, to whom I have to get the data. So address is always unique and it is always unidirectional. It is always unidirectional. Data is processed in to and fro operations, so it is bidirectional. Control bus is a bidirectional operation because it has to fabricate the data as well as to negotiate the data as well as to retrieve or to perform the operation based on the signaling cases. So it is also bidirectional operation. So control bus always initiates the operations to either to transfer or either to retrieve. Now, the next one is instruction cycle. So what do you mean by instruction cycle? So we said that data is loaded in instruction register, and we said that data is next programming the next code in the program is executed by means of program counter. Now, the instructions which you are fetching in the instruction register should possess what exactly it is meant for. For example, I am writing load. What is it meant for? I am writing add. What is that meant for? I am writing store. What is this meant for? I'm writing A by B. What is this meant for? So all these things are generally having some idea and basic importance. Now, we generally said that whatever the program you are executing, it first loads the instruction of first instruction into instruction register. Now, when the instruction register is holding the instruction current execution or current instruction execution, first it will fetch the instruction. First it will fetch the instruction. Next, it will understand the corresponding instruction. Next, it will execute the corresponding instruction. That means you are simply saying that current execution is done in instruction register, or current instruction which is taken, that is first loaded in instruction register. Next instruction is being loaded by the program counter. It is again repeated back until the entire operation is performed. Now, how these things are exactly performed. So for getting this, we have to know about the concept called as instruction cycle. So I have simply said with the load. Load means loading some data, adding some data, store, again reloading the data. Now, how these three things are being generated. So first the data will be loaded in the instruction register. Now this will be first understand, then it has to execute. That means first it is been loaded in instruction register. That means fetch operation is completed. Next, it is been understood what exactly the meaning of load. Load means we are simply loading the data into some register or some external sources. So we are just understanding the instruction. Third one is execute. So what is the meaning of execution? What is the meaning of that particular instruction? So we have to execute. Or else in simple terms, we can also say that let us write the simple instruction. So printf statement. What is the meaning of printf? The basic intention is to simply print whatever the data it is intended. We know that as a manual or as a human being, we know that because we have written these codes. Now, how a machine can understand by itself? For this, first it is been loaded into instruction register. That means fetch operation is performed. Next, it has to interpret. That means what exactly the statement meaning. So it has to understand. Now, what is the intention of printf? It has to print. So that has to be executed. So these are the three basic things which has to perform for executing a single line of instruction. Because of this reason, an instruction cycle is a combination of three phases. First one is fetch phase, second one is decode phase, third one is execute phase. So third one is execute phase. The next one is instruction cycle execution. So before getting for this, let us start with a simple operation. Now, for example, I want to load the content and I want to read the content. I want to perform two operations. These are the operations, for example. Operations. Now, first one is load. Load, or simply I can make it as write. I can also name it as write. Read and write operations. Now, what do you mean by read? Read means there is some location. I'll be calling that by means of the address. Once I locate that address, I'll fetch that data and I'll initiate. The data is been read. Data is been read. So first I have to locate the address, get the data, and in order to get the data, I have to initiate the control signal. So I have been processed with the read. Okay, this is a read operation. Now, what is the parallel operations of a write? So in the write case also, we have to perform the same thing. So data location is there. We'll fetch the address. We'll place the data and we'll present the write instruction. Write instruction. The difference between these two is it will first get the address, then fetch the data by presenting the read signal. But in the second case, address and data are readily available and it is loaded onto the location. So these are the difference. These two are the difference between read and write operations. Now, the instructions in machine learning or the instructions in a computer are generally executed by means of a timing diagram. I mean, the combination or execution has been presented by means of a timing diagram. The execution is taken care by means of a clock cycle. And the representation of this clock cycle is called as timing diagram. So here is the timing diagram where you have to concentrate. This is a read operation and this is a write operation. If you observe this, what is the read operation I am doing? First I am getting the address. Next I am getting the data by initiating the read signal. That means read and write are performed at the same time. In the second case, I am getting the address and locating data, getting the data before itself, and then I am initiating the write signal. That means read and address and data are processed at the same time. But in this case, read and data are processed at the same time. So these are the two differences which you are making. So first one is clock cycle 1, we are initiating the address bus first. Because of that reason, the address bus is started from the clock cycle 1 and it has been executed until the read operation is complete. Because of that reason, it is just going on. Okay. Second one is, we already said that first I'll trace out the location, then I'll move on for the read operation and data operation. So I'll initiate in the second clock cycle, I'll initiate the data which has to be read from the location by initiating the data with respect to read operation. Next one is write operation. In the write, already we said that address is identified earlier itself, data is also presented in our hands. Now we have to initiate the signal called write. So because of this reason, in clock cycle 1 itself, address and data both are initiated. And next, in clock cycle 2, the write signal is initiated to write down the data and corresponding location. So in this way, you are performing the write operation and read operation. And this is a way how your system is getting its internal operations to be executed perfectly. So what are the key components we have learned? So we have started with the basic definitions of a computer. So we have started with the computer definition. Next, basic components, operational concepts. Next, what are the things we have been learned over here? So the next operational concepts we have been defining with the objective of functional units, followed by computer organization with internal components connected by means of a bus. And we have been connected with the next case, how the communication is being done internally by means of a read and write initiation, by means of instruction execution and instruction cycle. So this is the way how you have to operate. So these are basic components which we have discussed in today's session. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.